So welcome to our physics class for today. What we have on the board is conservation of linear momentum. It's one of the principles of momentum, which states that in a system of colliding bodies, the total momentum remains constant provided no external force acts on the system. It can also be stated as in a system of colliding bodies, the total momentum before collision is equal to the total momentum after collision. It simply means total momentum before collision is equals to total momentum after collision. The principle can also be stated as that. So with that in mind, let's look at the question that we have on the board. The question says, a body of mass 6 kg moves with a velocity of 7 meters per second. This body now, if you read further, say it collides. This body of mass 6 kg moving at this velocity collides with the second body. If you look very well, the mass of the second body is not given. Collides with the second body moving in opposite direction to the first with a velocity of 5 meters per second. Further, it says after collision, the two bodies move together with a velocity of this. That is to say, they move with a common velocity. That makes this question to be an inelastic collision. We have two types of collision, elastic and inelastic collision. Since two bodies move with a common velocity, that makes them inelastic collision. So we are being asked to find velocity. Sorry, we are asked to find the mass of the second body. So let's try to solve the question and see where it takes us. So before the collision, first body, let's call it M1, first body. The first mass, M1, is 6 kg. Moving with a velocity, let's call it U1, 7 meters per second. Then second body, the mass is unknown. Let's call it M2, is unknown. Second velocity is 5 meters per second. So after collision, the two bodies move with common velocity v. Let's call that v as 4 meters per second, common velocity. So if we follow the principles of conservation of linear momentum that says total momentum before collision is equal to total momentum after collision. But let's draw the diagram to indicate the movement or motion of the two bodies. The first body is this, mass is 6 kg, traveling with a velocity of 7 meters per second. Collides with another body moving in opposite direction to this. This is the second body now. This time it's moving in this direction with 5 meters per second. The mass M2 and don't know. So this is before collision. Then what's happened after collision? After collision, we have the two bodies that they stick together and move with a common velocity. This is now 6 kg. This is now M2. They move with a common velocity of 4 meters per second. This is after collision. So with this now, if we apply the principles of conservation of linear momentum, total momentum before collision equals to total momentum after collision. What is momentum by definition? It's mass times velocity, product of mass and velocity. So this is the mass, this is velocity, this body will produce a momentum, mass and velocity, body will produce a momentum. So we are having two mass here times velocity, these two bodies will also produce a momentum. So if I state in the formula, I have M1 U1 minus M2 U2. Why am I putting minus in the second body? Because it's traveling in the opposite direction to the first. According to sign convention, here is positive, this direction is negative. So the first body is positive, second body is negative. That's why I'm putting negative sign in between them. So if the two bodies stick together and move the common velocity, after collision becomes M1 plus M2 bracket V. That is, the two bodies stick together and move with the common velocity of 4 meters per second. So let's substitute our value to see what the value of the second body is. Substitute our value to see what we have as the value of the second body. So we are going to have 6 times 7 minus M2 times 5 is equals to M1 is 6, M2 I don't know, velocity is 4. So if I multiply, that would give me 42 minus 5m2 is equals to, if I put this bracket, that would give me 24 plus 4m2. So to find m2, I will collect like terms. So 24 can come, 5m2 need to leave. So if that should happen, I'm having 42 minus 24 equals to 4m2 plus 5m2. So 42 minus 24 will give us 18 is equals to 9m2. So if I make m2 the subject formula, my m2 will give me 18 over 9, m2 equals to 2 kilograms. So the velocity of the mass of the second body is 2 kilograms. So thank you for watching. Subscribe, share, comment, and on your notification button. See you next time.